Welcome back. Today we're going to talk about the basics of graphing lines, circles, and parabolas. First of all, let's recall something about the coordinate plane. When we have the coordinate plane, we have a lot of things going on. And so let's label a couple of things. This is the origin. And the origin has its coordinates at 0, 0. It's where the x and the y-axis intersect. And if you remember anything about the x and y-axis, this is the x-axis and this is the y-axis. A couple of other things to remember. This is quadrant 1 and quadrant 2 and quadrant 3 and quadrant 4. Typically, they are denoted with Roman numerals. So it would be 1, then 2 i's, then 3 i's, then IV. So those are the basics of the coordinate plane. You already kind of remember that stuff. Inside the brackets, it's x, comma, y. Nothing new there, but that's going to help us when we start to graph these things, remember which one is which. Let's talk about graphing lines first. When we graph linear equations, the general form for slope intercept is going to be y, that's not a good color. Y, not a good color. That's better. Y equals mx plus b, where m is equal to the slope and b is equal to the y-intercept. And so we need to get this into slope-intercept form. Well, you'll notice we have y by itself. So solve for y. And that's to get slope-intercept form. Let's rewrite this equation and solve. 2x minus 3y equals 6. If I need to get y by itself, I'm going to move everything out of there. And to do that, I'm going to start by subtracting 2x from both sides. And we're going to have negative 3y equals 6 minus 2x. And I need to isolate y, get y by itself. So I'm going to divide by negative 3. And I'll have y equals, and 6 divided by negative 3 is going to be negative 2. Negative 2 divided by negative 3 is going to be a positive 2/3 x. And if I rewrite, y equals 2/3 x plus negative 2. Why did I write it like that? I like to eliminate the negatives if at all possible. And since I know that it's an mx plus b, that b is going to be the y-intercept, and so it helps me to write it in the plus form. How do I use this? Well, I need to plot the y-intercept. And I'll just make this one, negative 2, negative 3. And this will be 1, 2, 3, 1, 2, 3, negative 1, negative 2, negative 3. When I'm plotting these graphs, I need to first plot the y-intercept. So 1, plot y-intercept. And that y-intercept is going to be at negative 2. And so I'm going to plot that. And the second step is going to be use slope. Well, my slope is 2/3, and I remember that that's rise over run. And so I'm going to go up to 1, 2, and over 1, 2, 3. So I go up 2 and over 3. Now I can connect these dots to plot my line. And this line here that we have shown is 2x minus 3y equals 6, or y equals 2/3 x minus 2. That's the basics. Solve for y, Plot y-intercept, use the slope to find the second point. That should be a review from Algebra 1. Let's go on to the next piece. The next piece is graphing parabolas. This is nothing new, but obviously anytime we start to mix like A's and H's and K's and all that kind of stuff, it gets really confusing. So let's review. This is the general parabola equation. And on this parabola equation, we have to have this squared here because the parabola is going to look like a bowl shape, and that squared tells us that we have a bowl shape. General notes about this equation. H and K is the vertex. I've got this minus here, so that's going to be something that I need to definitely look at when I'm talking about the vertex. But H comma K is going to be the XY of the vertex. This A out front, this should actually be a little a. And I'm going to put it in quotes so that you know that it's actually the little a that we're talking about. It stretches or shrinks the graph. If it's less than 1, that means it's going to be flatter. And if it's greater than 1, it's going to be flatter. And if it's less than 1, it's going to be wider. It's kind of one of those things we just need to look at an example in order to do this. So let's look at an example. If I draw down here a coordinate plane, and I just do a general graph here of a parabola that looks like a bowl shape, and I call this y equals x squared. Well, let's look at what that really means. Really, y equals 1 times, and I've got x minus 0 squared plus 0. So my vertex equals 0, 0. And that's why it's right on the origin. So this vertex is right on the origin. So the general parabola graph is that x squared graph, but really if we note what h and k really are, they're really just 0 in this case. And that's where the vertex is going to be. It's going to be at 0. Graphing circles. Graphing circles is really actually a fairly easy topic because the circle equation is x squared plus y squared equals r squared. R is the radius of the circle. Let's graph a couple. Right here, I've made a couple of typos. This should be equals 16. This should be equals 1. Well, if x squared plus y squared equals r squared, then this is r squared and this is r squared. So r squared equals 16. So r is going to equal 4. And all I'm going to do is count 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, because the radius is the same all the way around. And I'm going to connect the dots to try to make a circle-ish. That's it. And I'll just label this 4 so that we know. Here we have a radius of 1, because r squared equals 1, so r is equal to 1. So I'll just go like this. That's all there is to graphing circles. So we graphed a line, we graphed a parabola, and we graphed some circles. That's all I got for today, guys. Thanks for watching. We'll see you next time.